Graph the exponential function using transformations. This is an exponential function that has both a horizontal and a vertical transformation. And the original graph that we'll be transforming is 3 raised to the x power. Y is equal to 3 to the x, has a horizontal asymptote at y is equal to 0, an initial value of 0, 1, and 2 other points of interest that are 1, 3, and negative 1, 1/3, which is the reciprocal of the growth factor. Let's recall that the growth factor here is 3, which is greater than 1, and that tells us that we're going to be working with an increasing exponential function. And this is the exponential function we're starting with before any transformations occur. Let's keep track of our points of interest in this table. We have the initial value, 0, corresponding to positive 1. The domain element 1 corresponds to the growth factor, and negative 1 corresponds to the reciprocal of the growth factor. And let's also keep track of the horizontal asymptote, y is equal to 0. Since both of our transformations are shifts, we can really do these in either order. So let's start with the horizontal shift that is left 1 unit. Remember, an inside shift is backwards from logic. It's going to affect the x values of the ordered pairs in a way that's backwards from what we see. So we're actually going to be subtracting 1 from the x values, which will have the effect of moving this graph to the left 1 unit. So we'll subtract 1 from the x values, and when we do that, we are not going to change the y values in this step. So subtract 1 from the x, no change to the y. X value is 1 minus 1 yields 0 for the x, no change to the y. Negative 1 minus 1 is negative 2, no change to the y, and since our horizontal asymptote is a y value and we're not changing the y values, we do not see a change to our horizontal asymptote. The next transformation is a shift down 2, which is going to affect the y values. These outside transformations are logical, meaning we do what we see when creating our new ordered pairs. So we start from having shifted it left 1. Now we're going to shift down 2, which means that we're going to subtract 2 from each of the y values in these ordered pairs that are our points of interest. Since we're changing the y values, we're not going to do anything to the x values, so no change to the x. Minus 2 from the y. 1 minus 2 is negative 1. And then, no change to the x, subtract 2 from the y coordinate. No change to the x. Now we're going to subtract 2 from the y value, which is 1/3. That's 1/3 minus 6/3, which is negative 5/3. So negative 5/3 is our corresponding y value. Since we're subtracting 2 from the y values and this horizontal asymptote is a y value, we're now going to land at a new horizontal asymptote, y is equal to negative 2. So let's put all this together and create our graph. We'll start with the horizontal asymptote, y is equal to negative 2. And let's plot our points of interest. We have negative 1, 0, 1, and negative 2, negative 5/3, which is almost negative 2, negative 2. And let's now connect these dots with an increasing exponential function that is approaching the horizontal asymptote, y is equal to negative 2, but not actually arriving there. Let's now check this answer on our graphing calculator by going to y equals. We'll input the exponential function 3 raised to the x plus 1 power, and then subtract 2. Then let's come over to our graph, and we see that our graph does appear to be correct, but let's check our points of interest by going second calculate, hitting the second button, selecting the calculate feature, and we'll look for number 1 in that menu, second calculate value. We can plug in the x coordinates of our points of interest to see and verify that they're in the right place. 0 corresponds to 1. We can just hit negative 1 to recycle through the second calculate value feature, hit enter to verify our negative 1 ordered pair, and then also our negative 2 should go with negative 5/3, which is 1 2/3, and that is the correct decimal for 1 2/3.